The same thing, okay? And what he's doing, right, it's catch trees, okay? He's trying to find out which, just a random sample, okay? The more samples you have, the better of your choices and so on, or probability and so on. The less it's, we can get more of those pairs. So he takes 100 boxes. He finds out the mean, which is 1.15, and then he also has the standard deviation, okay, of 1.17. So they deviate, right? Not bad. So he wants to find, boom, a 95% confidence interval. So what we need for this immediately would be what?
The formula.
That's right. And that formula, Mr. Epler and Company, is what?
Somewhere.
Well, right. What? Well, what do we have here? We got N, we got X bar,
right,
and we got sigma.
Yeah.
We got N, we got X bar, and we got sigma. I use that guy right there.
Perfect.
Yeah. So the confidence interval, the CI for 95% is equal to that madness right here, right? Parentheses. And I wrote plus or minus. Is that okay? Because I'm lazy. X, mathematicians are the laziest things in the solar system. Who would think of this stuff, Emily? Plus or minus, okay? Plus or minus what? Ooh, Z. Alpha over 2, or just Z. We'll be consistent just calling it Z. It's okay if you call it Z as well. Either one, it doesn't matter. Times sigma over the square root of N. All right, keep going. X bar was given to us as what, ladies and gentlemen?
1.15.
Rocket science, good. Plus or minus, oh gee whiz. I don't have a Z value. Wednesday, Thursday, Friday, what is that Z value, yes?
Well, can't you look on the table for 0.95 and find that probability?
That's true. That's absolutely true. And you guys are going to know that the Z value for 0.95 probability should be?
1.96.
Absolutely, 1.96.
Which is what you said.
Exactly, right? So it's going to be 1.96. Now, everybody's going to say, hey, why do you use the negative? Well, because there's a little minus sign, right? Yeah,
Yeah,
you do
'cause
both
it's
at the same
plus
time,
or
right?
minus.
That's
Yeah.
why that's there.
And all you need to do is find the probability of.
Yeah. What's sigma? It's 1.17.
Yeah.
Over the square. I'll get up. Oh, my bald head's making everything.
It's-
100, which is, I'll put 100 here.
Yeah.
You're right. So we keep going, right?
Yeah.
Want to tell me what the answer is? I don't know. 1.15 plus or minus 1.96 times. Well, that's 10, right?
Yeah.
You always point what? 117, right? So 1.15 plus or minus la.
1.96. Right.
So now you got to give me both values.
1.96.
1.96 for the low.
Times 0.117. We got ourselves 0.22932.
Point what?
22932.
For the low?
As blah.
Low.
No,
Oh, it's blah. So what did blah come out to be? I'll get out of the way, Mr.
0.22932.
And I have the high if you do the long
What's? Go ahead. Who gives me the high?
0.363.
Okay, 1.15 plus this guy, right? Take this plus this.
Oh,
Okay.
that's weird. Okay.
Well, because if you had a 0.2 or whatever it is, Sam's going to say, wait a minute, I took 100 samples and you found a 0.2?
37932.
That's the high?
Yeah, you're adding them together?
0.222932 plus 1.15.
Yeah, 1.37.
There we go. 379. Okay. What's the low? Has to be 1 point something. Right?
0.92.
Oh, 0.9. 2. So there it is. 95%. He's going to find those between a range of those values. Yes.
So this specific example is not on the worksheet, I don't think, but like it has similar examples.
Yes. 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 It's my college example from about 12 years ago. Yes.
So what do those numbers mean exactly?
Those numbers. Oh, so glad he said this. Okay. Oh. This does not mean, note bene, NB, note bene, no well, right?
Yeah.
This does not mean the 95% probability that the internal, that the stuff is contains you. It means that 95%, when you construct the values, right, construct the table, it will contain this value. So that means, right, here and here, you said what? 0.921. Right, I got to turn around like in the video. Remember the video, right? And smile. Okay. And then this one right here is 1.1337. 9, right? So we have a confidence interval that the mean will be associated in between those two, sandwiched in those values.
Okay.
But don't we already know the mean?
But we have a 95% confidence interval that it would exist in between these two, because you took a sample, right? This is this is what the company said.
You mean if they change?
Is it going to be always 1.15 on the assembly line?
No, so you
Oh.
mean. Oh.
Is every car going to be $15,150 for every place that you go?
No.
Let me know, please.
So this lets you.
Let me go
relate-
with you, buy a car.
This lets you relate one data set to all the others that would be similar.
Where is
to
it?
I was gonna say.
Yeah, because you got to do this stuff first. What happens? She has her company, A company, B company, and we make the same things, and we want to find out if Sam goes and he leaves and takes all of my trade secrets to go work with Billy. Is it good? Are the numbers are going to jive, right?
I was gonna say, because if you tell me the mean is 1.15, I'm 100% confident the mean is.
I'm 100%. Are you going to be 100% confident to find 1.15 through all the 100 samples?
No, but in this instance where you gave it to me. That's
Right.
why I was confused.
So Sam should find values in between these two on the line.
Yeah,
Okay.
that's how I
So
check.
the
1.15
confidence
does
interval
fall.
is in real world.
It happens all the time. This is
No,
big.
I mean, like,
Go ahead.
if the confidence interval is if you were to go
Oh,
out,
oh,
it
yeah.
would be in real world, it just wouldn't be the number.
Right. You would. Yeah, exactly. I know that for a fact. Yes. Right. And then.
Also,
Ms. Ryan.
you said there's the two different formulas where there's sigma over square root of n
Yep.
and sigma square variance over n.
Yes.
But those would give you different things because they're different ratios. So
Would they? Would they? Would they give you the same answer? I mean, if I gave you,
Because if
if I
you
did the
just
same thing.
taking the square root of
Well, I'd have to square the number, right? If you took sigma, 1 point whatever it was, right? 1.17, square it, and then only divide by 100. Didn't you tell me? Here, look at that. It's 1.17, right?
Alright, so
Then you
if we-
divided it by 10, right? If you took 1.17 squared and divided it by 10,
but then
Or
you
100.
You then divide by 100.
divide by
Yeah.
100, yeah.
And then you get.
What'd you get?
We closed it.
Pretty close.
1.7 times
1.17,
1.7.
because it's
Then divided by 100.
Yeah.
Well, yeah, square.
Yeah, 0.0136.
then I multiply it by the z in this guy.
Yeah, but that's a different number than last time.
It would be somewhat different.
It's only slightly off.
Slightly off. Slightly
But
off.
so why would you use the two different formulas?
Because
Because it's slightly different.
right there. Because it tells you that
So
variance
it's
is
just-
known. You know variance.
It's
If
just
you know
not-
variance, you know standard deviation.
Two different formulas that will give you different answers.
They will give you approximate, remember statistics.
Yeah.
So, right.
So either would be acceptable.
I would be acceptable, yes. Caitlin?
So the .921
Yeah,
and the 1.3,
yeah.
are those percentages or what?
No, they're true values, right? This is x bar of 1 and x bar of 2, right?
And those are the
those
answers.
suspected means. So he's on the line, and he picks the low end of .921, and he puts it away. Then he goes and finds a real high one of 1.379. That's the high guy.
So that's the confidence.
They're not the
interval?
confidence interval's the probability, right? Right?
Yeah.
And the confidence interval point P of 0.95 gives us a z-score of plus or minus 1.96.
So is that those two are the answers?
Yes,
Okay.
they're the ranges of the means.
So that's the odds basically that which you're probably going to find the mean in a different data set.
Yes,
Like on
Yes.
mean 1, that's your mean, that's your standard deviation. You use that to find the confidence interval.
Yes.
You can predict where the mean will fall.
I love this guy.
So
Yes,
you take
again.
the ingredient.
I should just,
Yeah,
I'm going to need a cigar after this. Yes, exactly, okay? That's absolutely right. Okay. Oh, is that it? Oh, no!
It's early release day.
All right. Well, guys, make sure I'll try to. Oh man, I don't know if I can leave this up or not. I'm gonna have to do something. I'll try to figure
Let's
it
take a picture of it now.
It's on video.
out. All right. So, ladies and gentlemen, make sure I do these guys here, okay?
Tomorrow.
Not that tough. I'll do this mañana,
Gotcha.
and I'll see this Miss Emma, Miss Cat testing later. Oh, get out of the way.
Wait up there.
Whenever I see the test.